How's it going? How's it going? How's it going, everyone? Welcome. We are Gonzalez. That's right. In today's video, what I want to bring here is the this notion of narrowing and wideness, or unioning and narrowness, specifically with Typescript and what this things is all about. So anytime that you need to find an enterprise scale application, and because JavaScript is very good at building these small prototypes, pretty much like when you write vibe coding apps. But when it comes to provide now long-term maintenance, now that's when as I, or perhaps the people that look at this, you need to understand is the fundamental. Again, it is something that is up to you. In my case, I do need to know, especially because first, this is a very cool and interesting way to exchange my time, my expertise, and my experience to help now some people to build this particularly applications for their business, and ultimately help them to grow their business from a technical standpoint. Okay, so this is great, and because there is a lot of tech involved, particularly several layers out there with different frameworks and here and there, it turns out that the fundamentals needs to be mastered, dominated, and that is understand what is the architecture of your computer, what is the different architecture that you can have in your machines, whether it's is x86 or MIPS or RISC, and perhaps also the ARM. So the idea is that once you started to understand these different layers that allows to use these computations, these machines that are tremendous, for example, in the e-commerce fields, or in the commerce, and in the business, finance. So, for example, to keep track of things that you need to have in your life, or to have a record of all these things that you have done in the past, like a transaction. So, pretty much like what the banking is doing, right? You have a huge layer that you add or remove things here and there. But that this layer acts as a record. This layer as act as a place where you can put all of your interactions here, right? And I know that there's a lot of people out there that they might anger about that, and how that's possible, and who do you think who you are, and yada yada yada. And it turns out that this actually works. So you're not seeing people doing things that doesn't work. And I'm going to get a little bit political. So, for example, in socialist countries, like where I came from, so if you don't have somehow a mechanisms to survive in the current state of affairs, so if you don't have reserve, international reserve in your country to manage or invest or spend on social security, welfare programs, and so on and so forth. So if you don't have that, so guess what? Exactly, you are not continue to allowed to, not even allow you, it is impossible for you to go that path unless you, of course, you have now resource. So resource and reserve. But the thing here is that when I mention this, right, especially from these socialist countries, or any place in other domains, So we do things that works, right? We don't hopefully do these things with, no, we do things that works. That's all. And it turns out that having this huge layer, which is something that a lot of these Jews, which were a so historically there has been a chase population for what they did to Jesus Christ. Whether if that is true or not, the fact remains. And if you feel threatened by your entire or by the entire world, you're going to now is trying to develop systems that allow you to now survive and thrive. So this is why the political and technology actually is integrated along with the art. So if you think that by looking at this kind of courses, you are going to live in a bubble that you're going to be maintained for X, Y, and Z company, so you are deadly wrong. Because you like it or not, this is also part of living as human in the 2021 century, right? So not only the technical aspect, also the social aspect of this. So the TLDR of this, at least model or series of videos, is to, from the creation of web applications that allow us to now have access from the browser to somebody else's documents that it live now miles away from us. So right now I'm living in Buenos Aires, Argentina, and if I want to, for example, have access to a DoorDash, right, which is something that is not here, but let's say Uber, and I want to um, pick up a, oh my god, pick up a cab, all right. So if I want to pick up a cab, I can do that by now signing here into this application, into this document that live on the, let's say, imagine that that live on the San Francisco servers, right? The reality is that they are now much closer through a series of corporate alliance, through AWS, Azure, Google Clouds, or any other providers like that. But the thing here is, now I can access and you can access to that website to do X, Y, and Z. Particularly on Uber, you can now is register and pick up a cab, right? That's great because now that has some real implications on the material world, right? So why am I mentioning this? As you build these small, perhaps forms and very nice little dashboards in JavaScript, and because the nature of this language is to describe things dynamically, aka you don't set things in stones like other programming languages, like compile-based programming language, whether it's C sharps, and because you need to continually provide support and add new features or remove old ones and add security patches, so you find yourself actually is as a company, not as a team or as an individual, as a company, you find yourself do these huge rotations for X, Y, and Z, right? That the idea, the team or that individuals involved in during the development, so they change, they go out and look at different adventures, or go out and work with different companies in X, Y, and Z, right? So do this nature of the development and the social aspect of building applications, So it turns out that a lot of those developers, at least back in 2011, at Microsoft say, hey, we need to find a way to make this kind of application, web applications, easy to maintain. That's why they come up with this script hash. That actually is, well, this superset of JavaScript that now allows us to statically, or to type is the data flow of this entire application. So this is not only great for user developer, but also it allows to detect errors not at runtime but at build time, and give us now an easy way for refactor our code, because it is heavily inspired on the C# features, like, hey, you have now is the IntelliSense. It allows you to now autocomplete those features, or allow you to autocomplete is or it suggests you with property and methods when you use, for example, the dot notation, right? Or help you to do some refactorings here, or organize your import alphabetically. So there is a lot of things here, and I just want to dive deep at least into this 4 topics in the next 20 minutes, because this is part of the model of unions and narrowing, what is relevant in today's video. And just to mention fairly quickly how do we get here, that's what I make this entire huge intro, right? A quick start, your Typescript setup, all right? Typescript in the build process, so how you can integrate now this Typescript here in your build development process, how that fits the essential types and notation and notations, right? How can we leverage is the Typescript superpower in our IDE? So, for example, by exposing or by using is the quick fix menu. First thing first, understanding is the statements and do some introspective about that. So this is a property, this is a methods, and that come from these particular objects, and this is now the interface, and this is what is the this identifier, this is the assignment here, and this notion of assignment is something that at least on unions and narrowing is quite important to understand. So this integrated tool, besides the quick fix menu, the auto completion features, the selecting target, and provide now some options in the quick fix to do some specific stuff, and also that how do you call it? How do you put it? See how you can now work with or help you to organize your imports alphabetically, which I do find that's quite interesting. How you can also out import things here, in how you can now go to a definition of the code, and by looking at the definition of that functions or function call, and where are the places that is being used, that's something that is powerful. It's tremendous, man. It's definitely tremendous. And how you can also now provide some code formatting pretty quickly using Prettier, and restoring the Typescript server when you see fit. So now here on the unions and narrowing is, again, the TLDR of this, okay, is that, hey, now that I do have this, okay, so these notions of assignability and understanding the null property, which is a part of the primitive in JavaScript, and how you can actually check that types and these notions of assignability into unions, right? So into unions and assignability, uh, by looking at how you can do that in your function parameters, define this union in your functional parameters or in your objects, or in the literal types, and how big this union can be. So it's preferred to go with more wide types, understanding now how you can actually select more wide types here, uh, understanding also the notion of narrowing and the concepts of unions and narrowing. Is anytime that you see, anytime that you're building an application that wants to cover a specific behavior or use cases, business logic, you do find yourself finding that that definition or that system now needs to change. So the TLDR is that, hey, anytime that I need to change something in my system, I can do that pretty quickly and understand what has changed and have access to that. So this is anytime that you want to represent is a new specific app behavior or use case or business logic. With Typescript, it allows you to provide maintainability to your applications, and you can see that. So by looking at also the narrowing and all this kind of stuff, and how you can work with the type of and the conditional type of, and narrowing with booleans, and by narrowing this type with type of and booleans, how you can also narrowing is on maps, because maps to the dynamic nature is something that TypeScript is cannot map that. So you need to is extract that value first and then work on that. The same for set, and also with tuple, how you can now narrowing or use unions for that. The same for objects, and here with object is anytime that you want to cover different scenarios, right? And this is a good example for API response or API response, whether it's a success or an error case. Okay, so how you can actually cover specific properties in those scenarios. What, to me, when I look at that, it's like, oh, it makes a ton of sense, you know. It makes a ton of sense, by the way. Absolutely, absolutely. So also how you can actually identify is properties in objects that you don't know from that beforehand. So using now the unknown, but you are know that you're gonna receive this property, and when you get that, well, you want to do something here. This is using now the in statement, narrowing unknown in large conditional statements as well. What is the never type, which if you have now the unknown, which is assignable to any type, so never is not assignable to none of this type, right? And with never, sometimes you want to throw now an error. So that's the use cases that you want to cover here. Again, typings here is trying to cover all the possible values that you application might be, right? Also narrowing in different scope. Unfortunately, this is something that you need to actually be explicit about with TypeScript. If you, for example, despite that you are checking is your properties, or even if you put now types on your identifier, let's say a parameter in a function, and that parameter is an object and it has nested properties. When you want to pull out some of those nested properties, Typescript, despite that you do this type check, if you want to pass that into a different context, Typescript doesn't work, doesn't like that, you know. So in those cases, it prefers to work with that explicit value rather than working directly with object notations, especially working in different scope. Again, this is part of the nuance with the Typescript, with narrowing your types. Also look at the reusable type guards, which is quite interesting, this type guard stuff. I don't remember too much about type guards. I do think that I am. Oh, so type guards, what it does is to actually create now a functions that is going to determine what is the proper type of this. And by this I mean is, for example, if in an object or in a collection and so on and so forth, when do we use this? So for example, if we are doing some data analysis here and somehow we need to create some sort of data transformations or some we're pulling data from different data sources, and we need to somehow create to consolidate that into one single data sets or into one single table, right? So now any of our applications that have access to our own data store can indeed have this consistency across the data. So this is one of the use cases when you want to run these type guards, right? So the use case for the type guard is that anytime that you, for example, wants to now is aggregates and consolidates several of these data sources, you do find yourself needing to create this new table or to consolidate the information in a known format, right? So that's why the type guard is tremendous here. It's quite useful here. Also, I look at handling separate but related types, right? This is useful again to cover now is how do you in a particular object that has optional properties, you want to now cover those scenarios. Handling separate but related types, destructuring and discriminating union type. TLDR is that do not use this because it's so far at least it's not worked the way it's supposed to. I mean you can work with, but again this doesn't useful at all. Narrowing at the discriminating union in with switch type, right? Which is a particular pattern of discriminating here union with a switch type. So the switch type pattern in Typescript here as well, which is quite interesting, you know, is this particular pattern here. But what I really care in today's video is about these last four topics. Refining types with discriminating unions of tuples. Oh, interesting. Oh, I already did this. Refining types with discriminating unions of tuples.
In this exercise, instead of talking about a discriminated union of objects, we're going to look at a discriminated union of tuples.
Exactly. Discriminating types with objects, and now it's discriminating types of tuples.
Have a fetch data function, which is an async function which returns a promise containing an API response. And this API response is a tuple. Now that tuple currently has two members. The first member is a string, and the second member is an array of users or a string. And let's kind of look and see what we mean by that. The first way that this tuple can resolve is basically by having, okay, we have a tuple which contains error as the first member of the tuple, and the second is a string containing the error that occurred. Then down the bottom here, we have another one, which is success, and that then returns the data. And you can start to see that we've modeled our API response a little bit inaccurately. We have kind of several possibilities. We can pass stuff into this API response that isn't error or success, and we can do the wrong combinations too. So we can pass in an error where we're in fact returning the data. So your job here is to figure out how you can change the type of this API response to be more accurate, probably using a discriminated tuple or a union of multiple tuples. And then inside the example func down the bottom, we want to check that this is working. And you notice that when we fetch the data, here we fetch the data and we get back status and value. We want to check if the status equals success, we want to console log the value, and we want, in that case, the type of value to be an array of users. Otherwise, we want the value to be a string here. So that's your job. And this is, I think you'll have all the pieces you need to understand this and get it right. And notice as you're going through it how TypeScript is narrowing and the clever things it's doing. And I'll see you in a minute.
He had a nice mic, bro. You got a nice mic. You got a nice mic, because I can even hear you when your fingers pass through your face, bro. Holy moly. Anyway, so yeah, so this is discriminating with tuple. Discriminating unions of tuples. So here, and by discriminating is, hey, this is the possible values in this union type. So in other words, whether I say is this with literals, whether I say, hey, this is success, or error, right? Is either one of them, not all of them, right? So is this, it can be either success or error, right? And the thing here is say, hey, now this is the done, right? So if this is success, is this one. So I'm expecting here to show you is with that. If I do this, I get now this as expected, right? So cool. Yeah, and okay. So now it say, hey, now you are passing here this discrimination, right? And when you try to evaluate here, to say, hey, the value here is now a user, which is quite weird because status is error or success. Here, if this is success, right? Okay. Okay, so it's mapping here. Okay. Holy moly. So whether you do this, so if this is success, it must be user. Okay, discriminating tuples here. So whether you do this, if this is success, this is an, okay, whether it's this is success or error, or if this is now an error, this is now an error, or an string, as it is, and this will work as expected. So you have now error, and you have now a string. It's not assignable in a string because it's not an string, my friend. So you either is a tuple with the success and user, or you are a tuple with error and a string, right? And it's interesting because the error says the string is not assignable to the user. Um, mm, 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 mm. So the API response, it can be either this, exactly, it can be either this. Oh, but that's interesting. It's not even detecting this another case, right? That's interesting. It's not even detecting that another. Oh, that's right. It's this one. It's this one. Yeah. Okay. But here is how you can say, hey, this is the API response. So you can say, hey, this is the type success response. You now encapsulate that or group that type to this. And the other is here, I want to say, hey, now type here on the error response, okay, and this will be the type here, right? So why am I doing is this, right? Because from readability perspective is quite actually interesting, right? Yep. From readability perspective is also awesome here. You got now success response and error response as it is, and with that, right? Now it say, hey, it can be either when this is a success response, is this tuple, or if this is now an error response, is this tuple. This is why now these union types are helpful for narrowing or widening the possible types here. And you are very explicit about this. That's a very interesting thing here. A very interesting topic here. Okay, narrowing with that. Narrowing tuples or union, exactly, discriminating unions of tuple and discriminating unions of objects here. Okay.
Okay, so API response now. We need to split these out into two separate states, two separate possibilities, because currently it's too wide, it's not helpful enough. So let's do the error state first. Let's imagine that instead of string, we now want to say, okay, one of the possibilities here is you return an error and then the string that comes with it, which is the message. Okay, nice. But now we're getting an error here saying success is not assignable to type error. Well, we can add a member to this discriminated union. And this is a discriminated union where we have success in the first one and then an array of users in the second. The discriminator is the first member of the tuple. So we have either the first one being error or the first one being success. And the first member of the tuple then defines the second member of the tuple. So error, string, success, user. And now everything inside the function works really nicely. So we're getting we have proper results here. So if I try to return an array of users inside here, it's going to error because, first of all, it says, oh my God, it's saying a bunch of different horrible stuff. Oh yeah, of course, because I'm actually trying to write some TypeScript in a JavaScript slot, so that wasn't good. So we have type empty object is not assignable to either of the possibilities here. So imagine if it was just an empty array, then we would get an error here saying type at position 1 in source is not compatible with type position 1 in target. So basically type this array is not assignable to type string. String is the only thing we can pass in this slot. But how about down the bottom? Because down the bottom, You notice that before we talked about destructuring indiscriminated unions and how you can't do it. Here we're destructuring, we're using an array destructure, pulling out the status and the value. And you might think in these situations, well, status and value, they're totally unrelated to each other. They're pulled into two separate variables. But TypeScript actually, with tuples and with discriminated tuples, it keeps track of that relationship. So if you check that status is success, then value is actually narrowed down by relationship. What?
Yeah.
How cool is that? This works for discriminated tuples, not discriminated objects. I don't actually know the reasoning for that, but this is how it works.
This works
and then
for
on the
discriminating tuples, but not for discriminating objects. That's interesting. So the relationship here with this mapping on that tuple, which is a special kind of property that array has in JavaScript, is that. So each one of those elements, so your collection is fixed, and each one of them are different, right? Different types, okay? And this is interesting for tuples, but this doesn't work for objects.
else branch here, then value is going to be string, and everywhere else it's either string or user. So cool, so clever. And it's actually a really nice use case for discriminated tuples. It's cool that TypeScript lets you do this, lets you return kind of like a double from your function in this way, lets you pull them out into different variables, and lets you kind of narrow them based on the value of the other. Very nice.
Yeah, but it's because it can map that, bro. It can map those here.
In this exercise, we're going to look at the fetch data function again that we've seen before, and we've refactored it back to an API response that kind of has a user array or string in the second member of the tuple, but it has a Boolean in the first one. So this is no longer a discriminated union, it's just a tuple type. But if we go down to the bottom, we can see that in our example function here, instead of destructuring the status, we're now just destructuring a succeeded value, which is currently a Boolean. And you can see here that if it does succeed, then we're checking if the value is this. Otherwise, we're checking if the value is a string instead. So your job is to work out how to type this API response to better represent these states. And this, I think, is a simple exercise, but it really clarifies something interesting about discriminated unions. Good luck.
So the error say, hey, type false does not satisfy the constraint true. And here. Oh, because he wants to be explicit about it, bro. Because you have to use now, you have to be explicit about here. If this is true, now you're gonna do this. Okay, here you are discriminating with booleans, but this is, if this is false, then you wanna show is now a string for that, my friend. Okay, again, we're working is with this discriminating union. And discriminating unions is something that I don't come up with that. That's in fact something that is here. Discriminating unions for functional programming. It's because it all comes from this. The closest equivalence to data is a union of type with discriminating property. Okay, the closest equivalence to data, and I don't see any data here. TypeScript for functional programmers here. Okay, so TypeScript again, it is live as an attempt to bring traditional object-oriented types to JavaScript, so that the programmers at Microsoft could bring traditional object-oriented programmers to the web. So far, so good. As it has developed, TypeScript system has evolved to model code written by native JavaScripters. I love it. The resulting system is powerful, interesting, and messy. This introduction is designed for working Haskell or ML programmers. What the French toast is ML programmers? Who wants to learn? What is an ML programmers? What is an ML programmers? Functional programmers. Meta language. Oh, the hell. Meta language. Oh, the hell. Who wants to learn Typescript? It describes how the type system of Typescript differs from Haskell type system. Okay, this introduction is like for working Haskell or ML programmers who wants to learn Typescript. It describes how type system of the Typescript differs from Haskell type system. It also describes unique features of Typescript type systems that arise from its modeling of JavaScript code. This introduction does not cover object-oriented programming. In practice, object-oriented programs in TypeScript are similar to those in other popular languages like OO features. Prerequisites. In this introduction, I assume you know the following: how to program in JavaScript, the good parts. Okay, that particular book. Yeah. That's interesting. It's like, hey, buy this book, bro. Holy moly. Okay. More than 5,000 organizations count on, oh really? Okay. Okay. Type syntax of C descendant language. If you need to learn the good part of JavaScript, read this. You may be able to skip the book if you know how to write programs in a call by value, lexically, scope language. Call by value, lexically, scope language. With this call by value, not by reference. So call by value, lexically scope language with a lot of mutability and not much else. R4RS schema is a good example. Revised report of the algorithmic language scheme. Okay. The C++ programming language is a good place to learn about C-style type syntax. Unlike C++, TypeScript uses postfix type. Like so, instead of this. Ah, look at that, bitch. Concept not in Haskell. Built-in JavaScript. JavaScript defines a built-in types. Number, a double precision, the ID exactly that follow this standard IEEE 754 floating points. Strings, an immutable UTF-16 string, big in integers in the arbitrary precision format. Number, string, an immutable UTF-16 string, big in integers in the arbitrary precision format, Boolean, true or false, symbol, a unique value usually used as a key, null, equivalent to the unit type, undefined, also equivalent to the unit type, in Haskell, an object similar to records. See the MD page for more detail. TypeScript has corresponding primitive type for the built-in types, like this, right? But other important types as well. Unknown, never, object literal, like this, property and type. Void for function with no documented return value. And there is never, the button type. the top type and the bottom type. Oh my god, here's when we're looking about this notion of holy oh holy hell, you have to read the docs, bro. Oh my god. And I see why you have this notion of this, the top type and the bottom type. The object literal, the void for function with no documented return values. So for example, functions that don't return anything, all right? For function with no documented return value, it return void, right? Mutable arrays, also reading like this, tuples in functions here, right? So note, function syntax include parameters names. This is pretty hard to get used to. Function syntax includes parameter names. Function syntax include parameter names, or more precisely, like this. Okay, you can okay, this is to describe is the dynamic type of this. Okay, this is pretty hard to get used to that. So this is how you can this is the this is the signature, or this one. Holy hell. Whether it's in this, right? Or this, all right? An object literal type syntax closely mirror object literal values as syntax. So for example, this is the signature of this, and this is the value here. And 3, this tuples is a subtype of T. This is different than Haskell, where tuples are not related to lists. And all of this is just describing is the basic notions of the Typescript for functional programmers. Okay, boxes type. JavaScript has a boxes equivalent of primitive types that contains the methods that programmers associate with those types. Typescript reflect this with, for example, the difference between the primitive type number and the box type number. Okay, and the box type. The box types are rarely needed since their methods return primitive. Their boxes, since their methods return primitive. Gradual typing. Typescript uses the type any whenever it can't tell what the type of an expression should be. Compared to dynamic, calling any as a type is an overstatement. It's just turn off the type checker whenever it appears. For example, you can push any value into any without making the value in any way, like this. And you can use an expression type any anywhere. Any maps for this. Any is contagious too. If you initialize a variable with an expression of the type any, the variable has type any too, like this. To get an error when Typescript produces an any, use no implicit any true or strict to in Typescript conf. Structural typings. Okay. Structural typings. Is a familiar concept to most functional programmers. Although Haskell and most MLs are not a structured type, its basic form is pretty simple. You just have this, you have this value assigned to that, and then you have another value, and this is the signature here, but with this. Here's the object literal x hide this. Okay. Here's the object literal here. Has a matching literal type. Xstring and extra, the type is assignable to Xstring, since it has all the required property and those property has assignable types. Or this one, right? The unions. In Typescript, union types are untagged. In other words, they are not discriminated unions like data in Haskell. However, you can often discriminate types in union using built-in tabs or other property. Why do in the first place we have discriminate unions? What is discriminate unions? Discriminated unions, bro. Discriminated unions. So what are discriminated unions from here, from unions here? And what is data in Haskell? And what data means in Haskell? What data means in Haskell as a JavaScript developer? Holy okay, read the docs, bro. Discriminating unions in types. Union types are on Typescript, on Typescript. They are not discriminating unions like data in Haskell. However, Typescript has a close equivalent. The close equivalent to data is union of type with discriminant properties, normally called discriminating union types. The key difference from Haskell is that the tag or discriminant is just a property in each object type, where each variant has an identical property. Okay, which each variant has an identical property with a different union type. For example, you have a kind property set to circle or square as a string literal on each variant. You can discriminate that the members of the union using normal JavaScript code, typically a switch or if on the discriminating property. When every type in a union contains a common property with literal types, Typescript considers that to be a discriminant union and can narrow out of the member of the union. A practical benefit is the return type of an area is inferred to the number because Typescript knows the function is total. If some variant is not covered, the return type will be number or undefined. This gives you a form of exhaustiveness checking. What data means Haskell for JavaScript developer perspective? In Haskell, data defines a type that can be one of several distinct variants, each potentially carrying different associated data. Essentially a tag union. As a JavaScript developer, think of it like defining an object that must be one of the several shapes. It is in this shape, and when we talk about shape, and when we talk about shape, we mean is the function argument. Is a function argument. Is the function argument, right? Check your findings. and provide links. If some variant is not covered, the return type will be number or undefined instead. Typescript, this gives you a form of exhaustive check, but anyway, I'm here. Of several shapes, where a tag field tells you which shape you are dealing with. The Typescript page frames in this way. The closest equivalent to data is union of type with discriminating properties. So Typescript, so in JavaScript terms, Haskell, data shape is equal to circle. Okay, data, okay, this data, the closest equivalent to data is a union type with discriminating properties. So in JavaScript terms, Haskell, data can be shape. So the shape, it is a circle, float, or square float. Translate roughly to this. Exactly, you can be either of one of these shape, bro. And not exactly. Shape in TypeScript is a broad concept than just function argument. One of the TypeScript core principles is that TypeScript focus on the shape that value have. This is something called duck topping. The shape refers to the structure of a value, meaning its property and their type, not specifically. Okay, the shape meaning the structure of a value. Okay, the structure of a value. So the kind property acts as a. Oh my God, this is. Let me now go with this and say, hey, yeah, because you love to hallucinate that, and I want to make these things explanatory, bro. Exactly, because it's the intersection of functional programming and TypeScript. And let me dive into some of the richer of both of these you are pulling here. Yeah, because it's like, what the French stuff is this discriminating union? And where these things are coming from? Oh, I know where it is. Mm-hmm. 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 Concept similar to Haskell. A concept not in Haskell. Building types, gradual typing, structural typing, unions, and union types. Concepts similar to Haskell. Contextual typing. Type aliases. Exactly, type aliases. Discriminating unions. Type parameters. Higher kind of types does not have a higher kind of type, so the following is not legal. Point-free programming. Point-free programming. Heavy use of currying and functional composition. It's possible in Java, but it can be verbose in Typescript. Type inference often fails for point-free programs. You will end up specifying type parameter instead of value parameters. The result is so verbose that it's actually better to avoid point-free programming. Type parameters. Model systems. Read only and const. Read the full handbook from start to finish. Okay, that is interesting. That's interesting. Okay. Holy moly. Yeah, it's like what the French does is discriminating values. You know what I mean? Yeah, because you talk about this, and this is from functional programmers here. Discriminating unions. And what is the usability of this? Yeah, and what is the usability of this? Discriminated booleans here.
Okay, the key idea from this exercise is that discriminated unions, the discriminator doesn't have to be a string. It can be a Boolean. And here we can do, basically we can turn this to succeeded true, and if it's true then we will pass the users back, or we will use false, and then in that case pass back a string. And so inside the responses that we're returning here, you can see we're returning false, and then an error occurred. If we were to change this to be true, then type string is not assignable to type user. Beautiful. And now the same behavior is true down at the bottom. We've got succeeded, which is true or false, which TypeScript just elides to be Boolean. Very clever. Then we've got value here, which could be string or user, and we're doing the same checks. We're checking if succeeded was true, and if it was true, then it's a value is a user. Otherwise, value is a string. So this works in discriminated tuples. It also works in discriminated unions of objects too. You can have like, it doesn't have to be just literal strings in there. You can have numbers in there. You can have booleans as they are here, and this works in the same narrowing sense as destructured tuples. Super cool. Okay, we are back with our calculate area function. We have a square and a circle again, and we have added, though, a new test case. This new test case is right down the bottom here. And in our previous test cases, we're checking if you pass a kind circle or a kind square, then it should calculate the area properly using a discriminated union. But down here in the calculate area function, it should calculate the radius when we don't pass in a member of the discriminated union, when we don't pass in a kind. So here we're sort of implicitly saying, when you don't pass a kind, you should treat it as if it were a circle. So here we're kind of like expecting a default behavior from our discriminated union. Interesting. Your job here is to try to find a way to express this, first of all, on the type level. So in these types up here, you'll also probably need to change around some of the stuff in the function body to get the narrowing working in there. Good luck.
Mm-hmm. Come on. Mm-hmm. In case or shape dot radius. That's interesting. Mm-hmm. Mm-hmm. So the point here is that if I do this, I should be able to have access to the radius and then do something with that. But if I don't, mm-hmm. Discriminating objects here. Discriminating object, discriminating property object here. Discriminating property object here. Mm-hmm. So if radius exists in shape, right? So now I do have that radius here. And then I can do my stuff here and compute that as it is, right? Now instead of checking for value, I'm checking is for properties here. Mm-hmm. And if side length exists and shape, it means that this is now a rectangle. So now we can do is this. Okay. Mm-hmm. Mm-hmm. So what I can do here is this. So now this will return is actually that, right? So now I am forcing to always return is a number. Mm-hmm. Okay. So but here I'm going to check is for that. Mm-hmm. Mm-hmm. But the point here is that I'm going to test that.
Okay then, so the most sensible thing we can start off with here is thinking about the kind of third state that we want our setup to be in. We have three kind of like inputs you can possibly add here. We have the one where you explicitly pass a kind circle and you get radius 5. Then we have one where you explicitly pass a kind square and you have to pass in side length. And you need to have one where you don't pass in one, so like an optional version. So what would that look like? We might have like an optional circle in here. And the optional circle would not specify a kind, and then you get radius number on here. So we could add this into here. So it would be circle or optional circle or square. Now this works from the outside of the function here. So we now figure out that, okay, you can pass in radius here and it should like return properly. All the test cases will pass, but inside here it's actually going to, well, actually, first of all, it's going to error in a couple of ways. It's going to error, first of all, because property kind now does not access, like it's not accessible on the type of shape. There's one of these members here which no longer has a kind on it, which means it's no longer actually a discriminated union. Okay, that's not particularly great, and that means that it breaks all of the logic inside here. So, this doesn't feel like the right solution. So I'm actually going to delete this and show you a slightly different version. Well, let's keep it around just for clarity, but let's remove it from our union. So optional circle, a kind of failed experiment. The other way we could do this is we could extend the type of circle to be something that doesn't require a kind. We can do that by actually adding in a little optional thing in there. So now type circle doesn't require the kind in here, or you can pass in kind as undefined. And so if we look at the bottom here, you can see now that we get exactly the same behavior. This is now working from the outside. We can pass in kind, so we can say it's a square, and if we pass that in, then it's going to require a side length, and radius won't be allowed to be passed. We can pass in undefined, which is nice. Now again, this defaults to a circle, and we get back kind circle here. Okay, nice, that's good. So that seems to be working from the outside of the function. But how about the inside? Well, if we look inside here, we can say if shape.kind equals circle, okay, this now means that this is guaranteed to be a circle inside here, that's nice. But now shape, or rather down the bottom when we check the side length, this is no longer being narrowed. This is because we're not checking to see if shape.kind is undefined in here. We could say if shape.kind equals circle or not shape.kind, then this should work. I'm not sure why that's not working, but I can't be bothered to figure it out because there's an easier way. We can basically just swap these around. We can say if shape.kind equals square, then check the side length there. Otherwise, check for a circle. So this is kind of a way to extend our discriminated union and add a default for it, where the one that has the optional kind property is the one that is the default. If we had more than one optional thing here, then it sort of wouldn't work, right? And it kind of wouldn't work on the outside of the function too, because we'd be able to pass in side length here and stuff. So having only one optional kind is really important if you want a default in a discriminated union. This is super useful in all sorts of abstractions where, for instance, you have a button component where you might want to make it into a link, so you maybe add an as link or something, but by default you want to treat it as a button. So again, defaults in discriminated unions are a really powerful way to extend this abstraction to cover even more possibilities.
Defaults in discrimination union. That notion is something that I don't understand. And that'll be all for this video, because I'm gonna do that later. So take care. Bye bye.